we're gonna try and tackle some harder questions or more application style questions of geometric sequences. Okay, so if we try to answer some of these questions, it's very important for us to know this term formula. Okay, so we're going to need to know this as we try and answer some of these questions. So let's try and do that. Now in question 1, it tells me that the number of cells double after each process of cell division. And there are 4 cells initially. Okay, so again, this question is describing a situation in which we have a geometric sequence. Now in part A, it tells me to find the rule after n divisions. Now finding the rule, what that is saying is I want to pretty much find my term formula. Okay, so from here, I want to find the value of A and also the value of R. Okay, I don't really need to find the value of n because I want it after n divisions. So A is the first term. Now it tells me that there are 4 cells initially. So at the start, there are 4 cells. So then my first term is going to be 4. And R for my common ratio, now it tells me that this number of cells double after each process. Okay, then my common ratio is going to be 2. So let's sub all the numbers in. Okay, and that's it. That's my rule for just part A. Okay, so that's after n divisions. Now we can use this to find the number of cells after 9 divisions. So finally we know we can sub in n equals to 9 into that formula. Okay, so how many cells are there after 9 divisions? Well, let's sub n equals to 9 and calculate this. Then I get, okay, after 9 divisions, I have 1024 cells. Okay, so that was a nice question to start us off. Let's look at the next one. Now in question 2, it says that the half-life of a 500 gram material is 1 year. And it says in part A to find the rule after n years. Okay, now the half-life of some material is talking about the material that decays after a certain period of time. Okay, and it's going to decay at a factor of halves. Okay, so again, finding the rule is just, I want to find the term formula. Okay, so to do this, let's find A and let's find R. Okay, and n is just, we want n years anyway. So A is going to say, we're going to start off with A equals to 500. Okay, now R, like we said, is the half-life. So R is the common ratio and it's getting degraded by a factor of half. So if we sub all these numbers in, so A is my first term, which is 500, and it decays at a rate of half. Okay, to the power of n minus 1. So this is the answer, but we can kind of simplify this down. Okay, so half we can rewrite as 2 to the power of negative 1. And if I multiply my powers out, then this will be my answer. Okay, so this is the general term or the rule after n years. Now let's just leave that up there. And in part B, it says, find the number of years that the mass is less than 1 gram. Okay, so again, this 500 gram material is going to decay after a long period of time, okay, by a factor of half. Okay, so this question is asking me, okay, after how many years will the mass be less than 1 gram? Okay, currently it's 500 grams. So we can use this formula. Okay, if I let that formula equal to 1 and I try and solve for n, which is how many years, then hopefully we can get the answer that way. Okay, so from this, the first thing I'm going to do is divide both sides by 500. Okay, so I want to find n, so let's try and isolate all the numbers away from n. Okay, so I divided both sides by 500, and to find n, or this power, I'm going to take the log of both sides. Okay, this is really good because I can use log laws and my power will come down to the front, like this. Okay, and again, we want to find the value of n. So let's divide both sides by log 2 and put the 1 to the other side and multiply both sides by negative 1. Okay, and this will be my answer. So again, the question asks us to find the number of years. So let's calculate this value. So put it into your calculator. Okay, and this is what we should get. So we get the fact that n, once we do all these calculations, we found that n equals to 9.96. Okay, then for the answer, I want to write, okay, it takes 10 years for the mass to get less than 1 gram. Okay, so if I say that it was 9 years, it's not quite there. That's why we just round up the next one, which is 10.